Hello guys, welcome to your channel Learning Point. Let us start with a very simple chapter, yet a very important chapter of your new syllabus of 12th standard, differentiation. We are starting with the basics today, which is also there for important for 11th standard. So let us start with the definition first of all. What is differentiation? Differentiation is a process of finding the derivative. So now you may think that what is the meaning of derivative? So let us see what is a derivative. Derivative is nothing but a rate of change of a function. So let us understand what is the meaning of the word rate of change. Suppose if we consider over here our x-axis and y-axis, and on x-axis these are over here representing the number of cars manufactured by a company, and on y-axis, suppose if I assume that it is the cost of production. So in that case, as the number of cars manufactured will increase, the cost of production will also increase. Probably something like that. More the number of cars, higher is the cost. So if I want to find out how much the cost is increasing, by how much the cost is increasing when the number of cars manufactured is changing or increasing, then I have to find out the derivative of the cost function. I assume cost function is Cx. So this particular curve is representing the cost function Cx, which you can see it is increasing from bottom and going over here till the top. So this kind of a graph can be obtained when I know the rate of change of cost. Okay, so basically derivative is nothing but in simple language rate of change. जितना कॉस्ट जितना कार्स मैन्युफैक्चर ज़्यादा करोगे उसके हिसाब से जितना कॉस्ट बढ़ेगा that particular value that I will get it can be called as rate of change of cost. Okay, that is a very simple definition that I have given it to you. Now we can assume over here if y is equal to fx is a function of x, then dy by dx, which is also called as equal to f dash x, denotes derivative of y with respect to x. Suppose if I draw a small line over here so that it can be separated. gives you the derivative of y with respect to x, or I can also call it as rate of change of y with respect to x. That is, if x changes by 1 unit, then there has to be a corresponding change in the value of y. So if I want to find out by how much the value of y is changing when x changes by 1 unit, then in such a case I have to find out the derivative of y with respect to x. Whenever we are talking about derivative, we always have to apply this notation dy by dx. This d by dx is a very important notation for you to remember, guys. D by dx over here, it is called as differential operator. This differential operator helps us to find out the derivative of a function. Now see, when we talk about finding derivative, then there are two basic methods to find out the derivatives. The sorry, the first method is by derivative by first principle, and the second method is by derivatives with the help of formula. So today we are discussing the derivatives with the help of basic formulas because this is more important for the 12th standard children. If we want to also find out learn the derivative of by using the first principle, it requires the application of limits. So we'll be doing it later on. Okay. So first let us focus on the second portion or the second part, which is more important for the 12th standard students, which is derivative by with the help of formulas. Now before directly going to formulas, there are some basic points that you have to remember, basic types of functions that you should know, everybody. So let us understand what are the different kinds of functions. Okay. The first one that I have is algebraic, or you can call it as polynomial functions. How should I identify whether the function is an algebraic function? Identification. We have a variable in the base and a constant number in the power. The constant can be positive or negative, whatever it is, does not matter. But if I have a constant number in the power, then such a term or such a function is called as algebraic or a polynomial function. Obviously, we'll see an example for this. If I have y is equal to x square minus 5x plus 2. So I can see that this kind of a function is called as an algebraic or a polynomial function. If I have y is equal to 2x cube plus 1 upon x square minus x. Again, this kind of function becomes also a polynomial function because I can see that 2x cube is already variable to the power constant. This 1 upon x square, if I want to simplify, I can write x to the power minus 2 minus x. I am sure you have studied the laws of indices in your smaller classes, which says a raised to m is same as 1 upon a raised to minus n. So this property helps me to bring the denominator value in the numerator with change in sign of the power. So that was about your algebraic function, guys. Now the next type of function that I have is called as exponential function. Now when we discuss about exponential function, once again I want some identification for this. So let us see. Just opposite of the previous case guys, algebraic we said it is variable raised to constant. In case of exponential we will say it is constant number in the base and variable in the power, then it is called as exponential function. Once again, if we take a simple example, y is equal to e raised to 2x, or I can say y is equal to 7 raised to 3x minus 1, or I can say y is equal to 6 to the power minus 5x square. So this kind of a function, when I am having a constant number in the base, see 7 is a constant, 6 is a constant, so these are constants. So when I have a constant number in the base, then this will be called as an exponential function because variable is there in the power. Now whenever I am seeing this e raised to 2x, again e is called as an exponential constant. We call this e as exponential constant, which has a fixed value. Its value will never change. It is an irrational number similar to pi. You have studied about pi guys. Pi value is 22 by 7, or you can say 3.14. Similar to that, E has also got its own fixed constant, but we don't need to remember that value now because we are studying about derivatives, so it is not required as of over here now. So but still you can remember that E is an irrational number, okay, which has a fixed value. Its value will never change. So that was about your exponential function guys. After that, the next type of function that we have is called as logarithmic function. Now what is the meaning of a logarithmic function? Whenever we come across the word log in the question, it is always a logarithmic function. Either I can see the word log, or you can also find the word ln. Ln also represents log. Then there are two different notations for log function, either log or ln. Meaning is always the same. For example, I can see log of 2x, or I can say log of 7x cube minus 1, or I can say ln 3x plus 1. So this kind of functions are called as logarithmic function. Just for your knowledge guys, you can remember that when you have the word log, it is assumed as base is 10. But when the word is ln, it is assumed that base is e. Okay. But whenever we are doing calculus, we assume that the base is e. So it is always easy for us to remember one uniform thing, that अगर log आया then the base is e in case of a calculus. So over here we write just log 2x or just log 7x cube minus 1. Am I clear? Number 3. Number 4 is trigonometric function. I'm sure you can identify the trigonometric function. Any trigonometric ratio which is sine, cos, tan, cot, sec or cosec. Sine 4x, or it can be tan 2x plus 1. So this kind of a function will be trigonometric functions. And the last type of function that you have guys is called as inverse function. Now how do we identify an inverse function? Identification. Inverse function is mostly coming under inverse trigonometric function. So in that case, in order to identify the inverse function, we can say it is -1 appears in the power. Then, if I want an example for this, this can be taken as sine inverse 3x minus 1, or you can say sec inverse 5x or something like that. This kind of a function will be coming under the inverse trigonometric function. So I am sure you must have understood the different kinds of functions guys. Now the next and the most important part that I have to remember over here, I had told you that we are going to do it with the help of our formula method, which is more important for us in the 12th standard. So let us see the different formulas and their answers. Function and the derivative. So we'll be seeing all the formulas with the help of our different kinds of functions that we have studied just now guys. As per the type of function that we have seen, we will see all the formulas one by one. So let us see what we can do in this. You guys have to remember the very first formula that I have over here is y is equal to k, where k is a constant number. Always remember, derivative of a constant dy by dx is always equal to 0. So what is the reason behind the derivative of a constant being 0? Just listen very carefully guys. I told you in the beginning that derivative represents rate of change of a function. Derivative is representing rate of change of a function. Now when I assume a constant, say for example 7, the value of the 7 will always remain 7 only. Its value can never change. So if the value of something cannot change, then there cannot be any rate of change. And if there is no rate of change, then obviously guys, the rate of change has to be 0. Therefore, the derivative of a constant function is always 0. How to identify a constant function? I'm sure you can recognize that whatever number that is added or subtracted in a function, that kind of a number is called as a constant function. So let us see over here. I am having some examples for you that we had taken in the previous case. See, this 2 over here, it is added. So this is called as a constant. This 5 is associated with x. So this 5 is called as coefficient of x. Always remember, derivative of a constant is 0. Derivative of coefficient is not 0. When we are solving examples, I'll explain you what we have to do with this 5. But for now, you guys remember that derivative of constant is always taken as 0. But derivative of coefficient is never 0. It remains over there in the answer like that only. Okay guys. So that was your first formula. Now the second formula. As I told you, we are going to see all the functions, formulas as per the functions that we have seen. So I'll explain you the next type of a function which I have, algebraic formula. Under algebraic, we have the first function which is y is equal to x raised to n. Derivative of x raised to n is equal to n into x raised to n minus 1. Just a quick example I will take for you guys. If I have y is equal to 3x square plus 2, then I can say that derivative of y, that is dy by dx, is equal to, as I told you in the very beginning guys, derivative of 3, that is a coefficient, is taken down as it is. So we write this 3 as it is. In case of x square, I can make it out. It is x raised to n with n is equal to 2. So when I want to find the derivative, I will get 2 into x to the power 2 minus 1, which is 2 into x raised to 1, plus derivative of 2, that is a constant number, so I write it as 0, and hence I get the answer as 6x. I hope that is a very easy example for you to understand the application of the first formula, which is algebraic guys. After that, there are a few more formulas that come under the algebraic section. So I will give you all those formulas and then we'll see how to apply those formulas in our examples. If I have y is equal to x, derivative of x is always taken as 1. Whenever we come across the letter s, x in our question, just we substitute 1 and we are ready with our answer. Number 4, y is equal to root x. Derivative of root x is 1 upon 2 root x. Derivative of 1 upon x minus 1 upon x square. Okay guys, so these are our basic formulas that we need for our algebraic function. After that, the next type of function that I have to remember is the exponential function. Now when we talk about exponential function, then the first and the most important formula under exponential function is a raised to x. Derivative of a raised to x is equal to a raised to x into log a. A raised to x, the derivative is a raised to x into log a. Okay, I'll give you an example for this. Suppose if I have y is equal to 3 raised to x, then derivative of 3 raised to x is equal to 3 raised to x into log 3. If I have y is equal to 9 raised to x, then I am sure you can give the answer very easily. It has to be 9 raised to x into log 9. Is that very simple guys? After that, the next formula that comes under this is is equal to e raised to x. Then in this case, dy by dx is given by e raised to x. That is the easiest formula ever in derivatives. Derivative of e raised to x is e raised to x itself. So in question, if I come across an example, let us say something like this. Y is equal to 5x cube plus 6 raised to x. Yes, so now you have to be able to identify the different types of functions, right? So 5x cube is representing algebraic, 6 raised to x is representing exponential. So when I want to apply my formulas, I have to be very careful with these guys. I have to write a very important statement in between, which is differentiating with respect to x. You can write it in short di double f. We will always write it like this, but because it is the first time that we are seeing, we are writing full differentiating. Otherwise, if you write it in short di double f, still it's acceptable. Okay guys, so differentiating with respect to x. Okay, so now derivative of y, as all you already know, it is dy by dx. I told you in the beginning that this 5 is the coefficient, so we cannot do anything with that 5. So leave that. X cube is representing x raised to n with n value as 3. What was derivative of x raised to n? It was n into x to the power n minus 1. So therefore the answer is 3 into x raised to 3 minus 1, that is 3 into x raised to 2 plus 6 raised to x is representing a raised to x. Just now we had seen the formula for a raised to x. It was a raised to x into log a. So in that case, what is the answer? 6 raised to x into log 6. So I can say that therefore dy by dx finally 15x square plus 6 raised to x into log 6. Is that very easy guys? So that was all about your exponential function. Now let us see the next type of function guys, which is based on your logarithmic formulas. Logarithmic function. There is only one formula under logarithmic case guys, number 8, which is y is equal to log x. Derivative of log x is equal to 1 upon x. So whenever we come across the word log in our example, we will always substitute the answer as 1 upon x and we are ready with our answer. Okay, let's take some quick examples for these formulas. Y is equal to 7x cube minus e raised to x plus to log x. Yes, so now you can easily make it out that I have taken all types of functions over here. Suppose if I take x raised to minus 3, still representing an algebraic function. So when I want to find out the derivative of this, as I had told you, I have to write differentiating with respect to x. So I get y is equal to derivative of y is equal to dy by dx, which is equal to 7 is the coefficient, so we cannot do anything with that. X raised to n, which is n into x raised to n minus 1. Should I write it for you? With n is equal to minus 3. So when I substitute, I get the answer as minus 3 x raised to minus 3 minus 1, which is minus 4, minus derivative of e raised to x. Yes, you got it right. E raised to x plus derivative of 2 into log x. Once again, guys, 2 is the coefficient. 2 is not the constant. Therefore, the variable, the value 2 comes down as it is, and we write derivative of log x as 1 upon x. Finally, I give a final finishing touch to my answer. Minus 21 x raised to minus 4 minus e raised to x plus 2 upon x. Yes, we can stop over here, but in case if you want to get rid of the negative power, what I can do is I can write minus 21 upon x raised to 4 minus e raised to x plus 2 upon x. So that completes your answer for derivative dy by dx. And as you know, we have to always highlight our answer with the help of a box. So we'll put that in the box. So that completes your basics of derivatives, guys. For more examples, will continue with in our next lecture. Till then, everybody take care. Have a good day. Thank you. Do like and subscribe our channel so far you can get the notifications of further videos. Thank you.